Two things explain why ethene acquires the shape it has, which is trigonal planar shape. One is a valence shell electron repulsion theory. Two is the type of hybridization of the valence shell electrons in carbon. Now let me explain the hybridization that took place. Ethene, the formula is this. This is the formula of ethene. And the hybridization that led to formation of ethene is sp² hybridization. Carbon has atomic number 6, and these 6 electrons are distributed into the orbitals thus. The last shell, the second shell is a last shell, so the s orbital of the second shell has 2 paired electrons. The p orbital has 2 unpaired electrons, having 1 vacant p orbital. Now this is the s shape, and these are p orbitals that have dumbbell shape, and this is empty p orbital. One of these electrons will be promoted, and we now have something like this. So this is the excited state of carbon, which is ready for hybridization. But being sp², one s orbital we mix with 2 p orbitals, leaving 1 p orbital unhybridized. So we have the hybridized orbital, 3 hybridized orbitals, having this shape, partly spherical and partly dumbbell, and 1 unhybridized p orbital having this shape. Now these are the 4 orbitals that occur around carbon atom in ethene. This is the carbon atom, and these are the hybridized orbitals, and 1 unhybridized p orbital. Now this will arrange itself in a way that the electron repulsion of the valence shell electrons, these electrons are on the valence shell, they repair themselves because they have the same charge, negative charge. This arrangement is wrong because negative charges cannot be at the same side. So the right arrangement is in a way that the electrons in these 3 sp² hybridized orbital will go as far as possible from one another, forming a perfect trigonal points, making something that resembles a triangle. You know, this is the perfect arrangement. So these 3 orbitals lie on a plane, and they are as far away from each other as possible, creating an angle of roughly 120 degrees Celsius, bond angle of 120 degrees Celsius. Okay. The unhybridized p will become perpendicular to the plane. Now, if we have another carbon that has acquired this kind of hybridization, in order to form ethene, remember, ethene is made up of 2 carbon atoms. If we have another carbon, the electron from it will be contributed to form a pair here. This is the carbon. These are the hybridized p orbitals. Then this is the, these are the hybridized orbitals, and this is the unhybridized p orbital. Remember, we have another unhybridized p orbital here, which is unpaired electron. So here we have bond angle 120, here bond angle 120, forming a trigonal shape. And the unhybridized p will form partial bond up, partial down, which leads us to something like this. The partial bond or pi bond, the pi bond formed by the unhybridized p orbitals is what contributes to the next bond, additional bond here. That is why ethene has a double bond linking 2 carbon atoms. So the second bond there is as a result of pi bond existing in between the 2 unhybridized p orbitals. So the shape of the molecule is as a result of 2 things: sp² hybridization, which leads to 3 hybridized orbitals, which move as far from each other as possible, creating bond angle of 120, which gives us a triangular shape resting on a plane. And that is why the shape of sp² hybridized carbon in ethene is trigonal